In this video I will explain section 11.2 Factorizing binomials. By now we know what factorizing means. It means writing something as a product, as a multiplication. What is a binomial then? Well, a binomial is a formula that has two terms. All of the formulas that you can see on the right hand page have two terms. What are terms? Well, terms in a formula are the parts that are separated by a plus and a minus. So as you can see, all of these formulas have two terms. In this section, I'm going to teach you how to factorize such a formula, so a formula with two terms. When we are factorizing a binomial, what we're actually doing is bringing back the single brackets. So what we did here in the refresh, exercise R4, when we removed the single brackets, that's the exact opposite of what we're going to do here. We're going to bring them back. And we're going to do that by looking for the common factor. My method is slightly different from the way the book does it. The final result is the same. So my suggestion is that you watch the rest of this video, read how the book does it, and then think for yourself what you prefer best. Now, like I said, we're going to look for the common factor. Let's start with exercise 16a. The formula that we have to factorize is n equals a squared plus 7a. If we're looking for the common factor, the first thing we're going to do is expand both of these terms as much as possible. And by expanding, I mean writing both terms as a product. So a squared, that's actually the same as a times a. The other term, 7a, can be written as 7 times a. And now it's very clear to see what factor is both in the first and in the second term is a factor of a. So that's a common factor. It doesn't matter if I circle the first or the second a in this term, anyone is fine. A is the common factor we were looking for. What you do with the common factor is you write it down in front of an opening bracket. Everything else of the formula, so this a and the plus 7, you copy down in between the brackets. Don't forget to write down n equals in the beginning to indicate that it's still the same formula. And we're done. We have now factorized this formula. As you can see, we have brought back single brackets. How can we check that this is in fact still the same formula? Well, we know how to remove brackets. That's what we have to do to check if it's still the same. So, if we do the two multiplications, a times a gives a squared, a times 7 gives 7a. So we indeed get the same formula that we started with. Now, this last part, the checking, is not necessarily part of the process, but if you're unsure whether you did it correctly, that's always the way to check it. So this is the final answer. This is how you factorize the original formula, by looking for the common factor, which was a in this case. Now, sometimes there's more than one common factor. Let's look at exercise 16c. The formula that we need to factorize is q equals 15b plus 45b squared. The method is the same. We're going to look for the common factor, but besides the b that they both have in common, there might be a regular number in common as well. So let's look at that. 15 can be written, for example, like 3 times 5 times b, because then we have the whole first term factorized. 45 can be written like 9 times 5, for instance, and b squared is the same as b times b. Now, one common factor is definitely b, but the factor of 5 I have in common now as well. So both of those things, the 5 and the b, I can write down in front of my opening bracket. In between the brackets I write everything that I haven't circled. So the 3 from the first term, copy down the plus in the middle, and the 9b from the term on the right. And this is the factorization of the formula that we started with. Again, if you remove the brackets, we're going to do it in our minds now. 5b times b, that's the same as 15b. And 5b times 9b is the same as 45b squared. So this is a correct factorization of this formula. Notice that I wrote down the formula again, because it can be done in a different way as well. We, for the regular numbers, chose the factor 5 as a common factor, because we split up 15 into 3 times 5 and 45 into 9 times 5. But we can also find 15 as a common factor. If we do that, then we can write down the first term as 15 times b, and 45 is the same as 15 times 3, of course, times b times b. Now, again, I have b as a common factor, but also for a regular number, the number 15. So what I write in front of my opening brackets now is 15b. In between brackets, I write everything that I haven't circled, which for the second term is just 3b, but it doesn't look like there's anything left from the first term. What number can I write down here so that I get the same formula again if I remove the brackets? Remember, you have to multiply, so 15b times 3b does indeed give 45b squared, but what do I have to multiply by 15b to get 15b? I hope you got the correct answer. It should be 1. If I have circled everything from one term, that means that I have to put a 1 in that spot between the brackets. That way, when I remove the brackets, I get exactly the formula that I started with. Don't forget the q equals to begin with. So basically, for this formula, we have two answers, two different factorizations. The first one and the second one. Which of these is correct? Well, the answer is both of them are correct. The second one is slightly better, however, because when you're looking for the common factor, when you are looking for something to write outside of the brackets, the best thing to do is to look for the highest common factor, and 15b is higher than 5b. So, when you can, please always circle as much as possible, look for the highest common factor. Why? Well, I said earlier that we're using factorizing as a method for solving equations later on, and the solving equation becomes easier if the highest factor is in front of the brackets. Now, in exercise 18 and 20, you have to look at binomials with negative numbers as well. So let's see how that works. In 18c, and then the first one, we get this formula, p equals minus 7q plus 21. It works the same way. Let's just break it up into different factors and see what the common factor is. So, nothing much I can do with the first term. Minus 7q can be written as minus 7 times q. 21 can be written as 7 times 3. So right now it doesn't look like I have a common factor, because this one is negative and that one is positive. But if I change this plus into a minus and make the minus 7, make the 7 a minus 7, then I have the same thing, because minus minus is plus again. So right now I have minus 7 as a common factor, which I can write in front of my opening bracket. Now the things to put in between the brackets is everything that I haven't circled. So q from the first term, now a minus in between the terms instead of a plus, and then the 3. Do we have the same formula if we remove the brackets? Let's check. Minus 7 times q, that's minus 7q, and minus 7 times minus 3, that's plus 21. So yes, this is the correct factorization. Please note that the plus here becomes a minus to find the common factor of minus 7. Last one that I want to look at is 20f, where we have higher powers for x to the power of 4, and x to the power of 7. Again, what we want to do is bring as much in front of the brackets as possible. So if we start by looking at the numbers, minus 24 and 32, they both have a factor of 8 in common, or minus 8. Let's make it minus 8. So minus 8 times 3 makes 24, and x to the power of 4 is the same as x times x times x times x. Then over to the other term, 32, like I said, also has a factor of minus 8. Minus 8 times what is 32? Should be minus 4. And then we have x to the power of 7. Hope this fits on my sheet. 2, 3, 4, 5, 6, 7. So obviously we can circle a minus 8. That's one term that we have in common. How many x's do I have in common? I have 4 over here, 7 over there, so I can circle all 4 of the x's in the first term, and then I can circle 4 out of the 7 in the second term. So what is my common factor? Minus 8 as well as 4 x's. That means x to the power of 4, not 4x. So minus 8 x to the power of 4 in front of my opening bracket. Just the 3 from the first term, and plus minus 4, 3 x's left, so x to the power of 3. This could be the final answer, but this of course is not very nice, so let's change that. Minus 8x to the power of 4, and then 3 minus 4x to the power of 3 in between the brackets, and don't forget y equals at the beginning. Is this a correct factorization? Let's check. Minus 8x to the power of 4 times 3. That's minus 24x squared. Minus 8x to the power of 4 times minus 4x to the power of 3. Yes, that's plus 32x7, because minus 8 times minus 4 is positive 32, and x to the power of 4 times x to the power of 3. Add up the exponents, we get x to the power of 7. So this is the correct factorization of the formula to begin with, and we made sure that we put as much in front of the opening bracket as possible. We looked for the highest common factor.